Welcome back to section 5.5. You already watched one video on this lesson where we introduced the law of sines or reminded you of what it was. One thing we didn't talk about that video on the front side are the situations where you use it. Since then, you've also watched 5.6, which is the law of cosines, and we learned that for law of cosines, you would use that anytime you're given side, 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 or side, angle, side. So just to review the law of cosines. Of cosines is when you know side, 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 or side, angle, side. Law of sines, maybe you figured it out kind of as you went, but you use that anytime you're talking about two sides and two angles. So either angle, angle, side, angle. And actually today's video is called the ambiguous case because we're going to talk about the third most complex situation for law of sines, which is when you're given side, side, angle. So again, anytime you know three pieces in that way. However, you probably remember from geometry that SSA is the one that we kind of say doesn't exist or doesn't work. It's not that it never works, it's just that sometimes it works and sometimes it doesn't, so therefore it's ambiguous. And so today we're going to learn how we can check to see if it does work in a certain situation, and if so, why that makes it more complex. So as we move into this lesson, we'll just keep in mind of when we would use those things. And before we get into the ambiguous case, we are going to flip to the back side of this worksheet that you've already done example 1 and 2 of. And we're just going to look at a real world example about using the law of sines. So example 3 on the back, an ore ship is traveling west. Towards Duluth on Lake Superior at 18 miles per hour. 18. The bearing of Split Rock Lighthouse is 285. So that's this is the first bearing from here. 285, I go all the way 3/4 is 270. So up here somewhere would be 285. After 1 hour, so we traveled 18 miles, the bearing of the lighthouse, the second time we checked the bearing to the lighthouse is now 340. More steep here. Okay, so because we have two different sightings on it, now we can say that this is where the lighthouse is. We want to know the distance between the ship and the lighthouse. Okay, that was the second there. Again, so in order to do that, we have one side length, which means if I'm going to use the law of sines, I would either need angle, angle, side, or angle, side, angle, which in this case, since I want to find the side, I really just find angles. I'm going to use these two bearings. Now I know for the 285, that gets me all the way to here, but I just want to know this little piece. So I know just to this line, it's 270. So to find that angle, I did 285 minus 270, which gives me 15. So this angle is 15 degrees. So when you're finding your degrees given bearings, we did this a little bit last chapter, but you just kind of have to start piecing things together. The other angle I know any information about is this one. I know that from straight up to straight across, this is 90. So if I can just figure out this little part, then I can add those together. Well, I know it goes to 340 and the whole circle is 360. So I do 360 minus 340, which is 20. So that little piece is 20, which means this whole angle is 110. Now, having said that, when I go to use the law of sines, I for sure need the angle across from the 18, since that's one side length I know, which means that's actually this angle. But since I know two angles in a triangle, I can easily find the third by 180 minus 110 minus 15. And so I get that angle is 55 degrees. So now I have enough information to be able to solve for D. I just have to pick the right pieces. Again, I know the 55 and the 18 are across from each other. So I'll say that 18 or the sine 55 degrees equals, and I'm trying to solve for D. So that's over sine of the angle across from it, which is 15. My cross multiplication, and I get D sine 55 equals 18 sine 15, and divide by sine 55. Type that into my calculator. Again, don't forget to make sure it's in degree mode, and I get that the distance from the second sighting to the lighthouse is 5.69 miles. So again, just a real world application of using the law of sines, and we're actually going to spend the day doing application stuff later this week. So now that we've kind of introduced and learned about the law of sines, we now need to look at this situation where we call the ambiguous case. So when we look at example 4, it says angle A or alpha is 65 degrees, side A is 4, and side B is 12. And now you'll notice it says if possible. Because when we go to draw this, and now anytime you're drawing the ambiguous case, I recommend the lower left-hand corner is the angle that you're given. We'll call it angle A or alpha. The side across from that is 4 then. And then the other side that I'm given, I'm going to put this diagonal. The only reason I recommend that is because when we get to the most complex situation of the ambiguous case, which is actually where we have 2 triangles in the end, this is the easiest way to get a visual. Okay, so now when I go to do this problem, I'm going to take the sine of 65. So my goal is to try to solve the triangle. So I'm going to try to solve for beta first. Okay, so I would take 12 over sine of beta equals 4 over sine of 65. When I do that, I cross multiply, I get 4 sine beta equals 12 sine 65. Divide by 4, and then I would take the inverse. So beta equals sine inverse of 12 sine 65 over 4. The problem is, when I go to type that into my calculator, so I go inverse sine of 12 sine 65 divided by 4, my calculator actually says sometimes when that happens, we think we just made a mistake. But in this example, if you recognize again that I'm given side angle, you're given side angle, it's the ambiguous case of law of sines. Okay, so it's the ambiguous case when that happens. So as soon as you have that, you actually have to check it on your calculator, and you'll see that it doesn't exist. So actually no triangle exists. This is why when we're just learning geometry, they tell us SSA doesn't work. Now, having said that, the other option you could have done, if you just type this part in your calculator, so what you were saying sine equaled, if I do 12 sine 65 over 4, I actually get 2.7, which means that we were saying that the sine of beta has to equal 2.7. But remember that sine only falls between, negative 1 and 1, so we can see that that doesn't fall within the range of sine. Having said that, I don't usually think about it that way. I would usually just type it into my calculator because that helps me. Okay. So sometimes when we have SSA, what we learned is true. It doesn't work. But let's look at another example. Okay. In this example, we see that, again, I follow my rule where I'm going to put beta down here because that's the angle they give me. That's 54. So side B is 22. And since they give me A, I'm going to put A here with the 24 across. Okay, so in this case, when I go to do this problem, I would start the same. Okay, so I'm trying to find angle A first. So I would do 24 over sine of A equals 22 over sine of 54. And so in this case, when I get 22 sine A equals 24 sine 54, I would ultimately end up with sine A equals sine inverse of 24 sine 54 over 22. And this time when I did that, I got that okay, and so if angle A is 62 degrees, then I am actually going to be okay, and this is going to work out. Okay, so I can continue solving the triangle. So I'm going to just say then this is 62 degrees. Angle C then is 180 minus 62 minus 54. That gave me angle C. I'll call it C1. We'll talk about that in a minute. The angle C is 64 degrees. 62 54. Yep. And then last but not least, I would find side length C. So I would say that C over sine of 64 degrees equals 22 over sine. So ultimately, I'm going to do 22 sine 64 divided by sine 54. I don't show all my steps anymore. I got that side is 24. So I found all 6 pieces. But here's the problem when you have this situation. Okay, now in both of these examples we've done, we were given this angle in the lower left corner. And note that the side across from that angle was smaller than the other side. Okay, and that's actually when you're going to have to work towards this. So once that's smaller then either you're going to have what happened in example 1, where there's a domain error, so no triangle exists, or if what happens in example 5 happens, so we know this angle, the side across from it is smaller than the other side given. If one triangle works, it actually means there's 2 triangles that exist. And here's why. If I draw that same picture, so this could be a 54-degree angle, this can still be 24. That side that originally I drew an acute triangle for, so it goes out like that, that side could come back this way and actually cause it to be an obtuse angle for angle A. Okay, so it makes it an obtuse triangle. So that's why it's confusing, is there's 2 different triangles that could actually fit that mold. So to find this is my information for my first triangle, I just solve it normal. But then for my second triangle, the A I get for the first one, angle A, and the second one is going to be the complement of that, which means I'm going to do 180 minus 62. So my other option for angle A2 would be 118 degrees. I would like to draw both pictures so I can get a visual, 118 degrees. And then, so for angle C2, I would do 180 minus 118 minus 54. And when I did that, I got 8 degrees. You can see how I adjust everything. And then finally, I can find little C2, which would be C2 over sine of 8 degrees equals 22 over sine of 54. So the length of C2, 22 sine 8 degrees over sine of 54. That side C2 would then be 30.78. Okay, so that's why it's the ambiguous case. When you're given side angle, if its side across from the angle given is smaller than the other side given, you're either going to have 0 triangles or 2 triangles. The way I do it is I start doing the problem. If I get a domain error, it reminds me that there's no triangle. But if it works, then I have to find that second triangle by finding the complement of the first angle that I was given, and then I solve from there. Now, the last thing with the ambiguous case, you could be given side angle, where the opposite side, they say, is longer. Okay, so let's say they give me that side A, or angle A is 35 degrees, and they say side A is 27. But if they say that side B is 20, this would be a situation where there is just one triangle, so you can just solve it. Okay, so there's 3 different cases. First thing I check for is the side across from the angle given, is it longer or shorter than the other side? If it's longer, just solve, it's one triangle. But as soon as that side across is shorter, like in examples 4 and 5, then I try to solve. If it doesn't work, no triangle exists, and if it does, I have to find that second triangle. And that is the ambiguous case. Now have enough information to move on and finish the rest of assignment number 1 that you didn't do last time. Thank you.